We're going to continue with discussing measures of center, continuation of from part one, this is part two. And now in the last discussion, we calculated the mean and the median by hand. Now we're going to do this using SPSS. Now what I'd like to do is go into SPSS, and I'm going to grab the heart rate data. So I'm going to go to Analyze, Descriptive Statistics, and Explore. And so I'm going to pull up the heart rate data. I did something earlier with credit. So this is heart rates from students from a previous semester. So I'm going to click on heart, okay. I'm going to click on OK. And what you see here, coming up here, is there's a lot of different statistics, but the two is the mean and the median. The mean is 72.45, and the median is 72, and the mean is 72.45. Okay, so now, so what I'd like to do now is to explain the differences between the mean and the median given certain distributions. Now, with a right skewed distribution, the mean is always larger than the median, meaning that the mean is going to be to the right of the median. Okay, with a bell-shaped distribution, the mean and the median will be very similar and possibly close to the same. Okay, now with a left skewed distribution, the mean is going to be always smaller than the median. Now the reason for that, in this case the mean being smaller and then the mean being larger over here, is that it's the outliers over here that are going to drive that median further away to the outside. So if we have outliers here, the mean is going to be pulled this way, so that means the mean will be larger than the median. And then over here, the mean will be less than the median because the outliers pull the mean over to the left, okay? Now the median is resistant to outliers. However, the mean is not. Okay, so for instance, let me go back to SPSS. And what I'd like to do is I'd like to look at the heart rate data again. This time what I'm going to do is I'm going to do graph, legacy dialog, and I'm going to do histogram. And so I'm going to pull the heart rate data. And let's see, here we go. Here's the heart rate. And then when I run that, what you will see is that the heart rate, if you notice this here, it seems to be somewhat bell-shaped. But what you notice here, what stands out? Well, there's a couple of heart rates that are close to 20, which I don't think is possible. I don't think that makes sense, but these two would be an example of an outlier. So what I'm going to do is that I'm going to go to the data. I'm going to pull out those two numbers, 20 and 21. I don't think that's possible for somebody to be, it's probably somebody nearly dead. 21 and 23. So now what I'm going to do is I'm going to go to Analyze, Descriptive Statistics, and Explore again. And now I'm going to do the heart rate data again. And notice what happens here when I run it here. When I go back, let me just go up a little bit here on the output. Notice the mean was 72.45, the median was 70. But notice what happens here is that the mean goes up, but the median stays the same. Those outliers, when you yank them out, that caused the mean to go up, but the median stayed the same. So to summarize here is that the mean is the median, is resistant to outliers. If you put them in or yank them out, the median won't change that much, if at all, but the mean will change. Definitely, at least more, it'll change more than the median. Okay. Now, one more thing I want to show you is students who've taken the amount of credits they've taken at a certain point. So what I'm going to do is I'm going to go back to the SPSS, and I'm going to do graphs, legacy dialog, and I'm going to do histogram. And now I'm going to pull in the credits data. Okay. Now the distribution of credits, when you look at the histogram, when you see this, what type of shape is this distribution? Well, the tail is on the right, so it's going to be a right skew distribution. You see the mean up here, and standard deviation, that'll be in the next video. But the mean is going to be slightly higher than well, I just about answered the question. The mean is about 60.12, so if you compare to the median, which is larger, the mean or the median? Well, what we can do is we can check that by doing descriptive statistics and explore. And then I'm going to, pull the heart rate data out, pull in credit data, and click on OK. And what you'll see here, it confirms here that the mean is larger than the median due to it being a right skew distribution. And that concludes our discussion of comparing the mean and the median with center of a quantitative distribution.